Hi everyone, today we're going to talk about question 9 on the June 2025 Earth and Space Science Regents exam. So let's get started. As always, underline or highlight unknown words, word meanings, context clues, or important details on what a graph, diagram, or text is about, any relationships between things, and circle any task verbs that are given to you. So it says, since the Industrial Revolution, deposition of dark particles such as dust, dirt, and rock in glacial ice, which is contaminated snow, have caused glaciers to darken. This has led to feedbacks that have caused changes to other Earth systems. Okay, so I'm highlighting the Industrial Revolution. Seems to be a context clue. I know from background knowledge, during the Industrial Revolution, there was a lot of pollution going on. Lots of greenhouse gases being released into the atmosphere, lots of deposition of dark particles such as dust, dirt, and rock were released. So I'm highlighting that as well. It gives me a context clue. And this dirt, and rock was released in glacial ice, and this means it contaminated the snow. So I'm highlighting that, and this has caused glaciers to darken. This seems to be a relationship or an impact, so I'm highlighting that as well. This has led to feedback, seems to be an impact or relationship, highlighting that have caused changes to other Earth systems. So it's giving me an idea that a lot of dust, dirt, and dark particles were released during the Industrial Revolution. It contaminated the snow and the glacial ice and causing the glaciers to darken. This has led to feedbacks that cause changes to other Earth systems. So I'm looking at this diagram and I see that from the contaminated snow that it mentioned here is right here and also right here. And then there's fresh contaminated snow. It seems to be a little lighter with tiny dots of what seems to be dust. And the older contaminated snow is a lot more darker with lots more specks of dust in it. We also see old snow, which is cleaner. We see fresh snow. We see light coming in. It also gives me a key showing sunlight being reflected or sunlight being absorbed. Now, I'm also seeing a graph here. It shows yearly and cumulative ice loss for 37 glaciers. The yearly ice loss is in meters of water, and this is the axis for that. And then I see cumulative ice loss, which is meters of water. So I have yearly and I have cumulative. Yearly means every year, so that's the bar graph. So every year I'm seeing how much ice is being lost, and then cumulative meaning all together. So overall, this is the total overall general loss of ice throughout time. The line over here. Okay, so now that I know this, I see that the ice is going lower over time. We're losing a lot of ice over time, and yearly it's kind of fluctuating, and that can be due to summer or winter. Actually, it's saying yearly, so yearly it can be different because of different factors. So number 9, which model correctly represents the feedbacks that occur when dark surfaces are exposed in glacial areas and cause changes to one or more Earth systems? So I'm highlighting model because these are all different models or flowcharts given to me. Which model correctly represents the feedbacks? We're seeing that word again. We saw that before over here, feedbacks. So I'm highlighting that occur when dark surfaces are exposed in glacial areas, and cause changes to one or more Earth systems. I'm highlighting dark surfaces, and we're trying to figure out what's happening to these dark surfaces when they're exposed in glacial areas, and changes are they causing to Earth systems. Okay, so 1, 2, 3, 4. I'm seeing they all start with increase in dark surface area on glaciers. Okay, so because of the Industrial Revolution, we're adding lots of dark surface to the glaciers. What happens next? It's increasing the absorption of energy from Earth's surface. That seems to be the same for all of them. So dark surfaces normally absorb a lot more energy than light surfaces, but is that decreasing or increasing the melting? Let's look at the table of contents real quick. There's not much about glaciers, so we need some background knowledge. First, you need to know what absorb and reflect means. Absorb means to take in. The amount of energy that is being absorbed is in black, how much energy is being taken in by the surfaces. Reflect means to bounce off, so that's in white. And we see that a lot of them are bouncing off radiation, right? So some are absorbing more and some are absorbing less or reflecting more radiation from the sun. I see that we want to know what happens to dark surfaces in glacial areas. And I see that the darker the surface is right here, the more they're absorbing the black arrow and the less they're reflecting or bouncing, the light is bouncing away from them. Fresh snow, which is less dirty or dark, is actually absorbing a lot less sunlight and reflecting a lot more, 90%. So even if you didn't know dark surfaces absorb more light, you can gather that from this information given to you. So that's why I know it's number four. An increase in the darker surfaces like contaminated snow, that's old, increases the absorption of energy on the Earth's surface. The black part is a lot more. Only 30% is being reflected compared to the other areas. See, the ground is the darkest part, and it's only reflecting 15% and absorbing most of that light. So it must be 4, and this increases the glacial melting. If you're absorbing a lot of light or a lot of sunlight, it's going to warm up a lot more compared to other areas that aren't absorbing much light. And that's going to cause the glaciers or the ice to melt. And if the ice is melting, then this should decrease glacial ice. So you can gather a lot of information from different areas, from your background knowledge, from the text they're giving you, or graphs, charts, diagrams they're giving you, and so on. But just so you know, albedo is the amount of light reflected by a surface, and lighter objects that actually have a higher albedo. They absorb less sunlight and reflect more sunlight, just like this fresh snow. Versus darker surfaces, which absorb way more sunlight and reflect a lot less of it. And it creates a positive feedback loop, which is a cycle that worsens over time what the original conditions were. So if we have lots of darker surfaces now because of the industrial revolution, those darker surfaces increase the absorption of light, and this increases the temperature of surfaces, causing the snow and ice to melt. And as snow and ice melts, even more darker surfaces are revealed, such as the ground. And this causes the albedo to reduce, meaning less light is being reflected by the surface and more light is being absorbed, and then that increases the absorption and causes this loop where darker and darker surfaces are being revealed, causing the earth to get warmer and warmer. In the next question, or in the next video, we're going to talk about question 10. So I'll see you later. Bye.